Hello and welcome. This is Teacher Juma again. Continue with the Form 4 syllabus. So our topic that we are handling in our lesson number 1 will be metals. So we are starting a new topic, that is metal. It's our lesson 1. So we are first going to introduce or to do the introduction of metals. So from Form 2 work, the periodic table. From the structure of the periodic table, we have the groups and the periods. So we have group 1, group 2, group 3, group 4, group 5, all the way up to group 8. So I'm interested with the first 3 groups. So the first 3 groups, then we have the periods. So for the first 20 elements, usually we go up to period 4, up to there. So where we have at the top here, we have hydrogen. Then group 8 there will have helium. Then we have sodium, lithium, beryllium. Then, so going down, we'll have sodium. Then we'll have potassium, calcium, sodium, magnesium. And then in group 3, we'll have here aluminium. Then boron. So I'll be interested with this first part. So here, from group 1 to group 3, this is where we have the metals. And then from group 4 to group 8, we have the non-metals. So my concern will be here now. So metals. So these are the elements that we are going to look at. The metals, the extractions, properties, and uses. So between group 2 and group 3 here, we have a group of elements which are called transition metals or transition elements. So they are still also metals. They are called transition. Why they are called transition metals is because they exhibit some properties of group 2 metals and some properties of group 3 metals. For that reason, they cannot be properly put either in group 2 or group 3. So they show some properties of group 2 metals and properties of group 3 metals. So some of the metals that we are going to look at will include metals from this region, the transition elements or the transition metals. So we are going to look at this one, extraction of sodium, extraction of aluminium, and then we are also going to look at some other metals, some of which will come from that group and others that are beyond elements number 20. So for the Form 4 syllabus, mostly we consider the first 20 elements. However, we are not restricted. We have to discuss some of the common metals, like for example, the metals that we're going to look at their extraction and properties. We'll look at sodium, we'll look at aluminium, we're going to look at zinc, we'll also look at iron, zinc, iron, then we'll have lead, and finally copper. So these are the metals that we are going to discuss, these 6 metals: sodium, aluminium, zinc, iron, lead, and copper. Now, metals are extracted, or the compound from which metals can be extracted is called an ore. A compound from which a metal can be extracted is called an ore. So we can define an ore usually as a rocky is usually a rocky material from which a metal can be found in its free form, in which a metal is found in its free form or combined with other elements. And then the ore in which the metal can be obtained on a large scale for commercial purposes is called chief ore. Chief ore. So the chief ore is an ore from which the metal can be obtained from or on a large scale or for commercial purposes. So that means there are some ores, they will have metal can be extracted from them, but in very small quantities. So those ones, we don't refer them as chief ores. But a chief ore is the ore in which the metal can be extracted on a large scale. Now, some of these metal ores are found in form of oxides. So the ores will be found in form of oxides, sulfides, carbonates, and even sulfates. So we're going to see some of these in which, and I'm not forgetting the chlorides. Like for example, this for calcium, if we were to discuss calcium, then you find the ores of calcium are in sulfate form, like the gypsum, which is in sulfate form. But these ones that are going to look at, the 6, mostly none of them is going to be in sulfate form. Most of them are going to be either oxides, sulfides, chlorides, or carbonates. So let me just project a table of some of these metal ores and their formula from which they are extracted. So here are some ores of some metals. So we have, for example, sodium. Sodium, the chief ore. So the one that is in bold, the ones that are in bold are the chief ores. Then those that are not bold, that's ores. As I've said, a chief ore is one from which the metal can be extracted on a large scale. So we have sodium chloride. So the other name, or the commercial name, is rock salt. The formula there, sodium chloride. Aluminium, we have 3 ores of aluminium. We have bauxite, which is then the chief ore. We have mica and corundum. Then their respective formula is as shown there. Then we have zinc. Zinc has 2 chief ores. We have zinc blende, we have calamine, and zinc oxide. And their respective formula are those. Then we have iron. So iron, the chief ore for iron is hematite. The formula is that. Then we have magnetite, siderite, and pyrite, whose formulae are as illustrated there. Then for copper, the chief ore for copper is copper pyrites, whose formula is that. Then we have other ores from which copper can also be extracted, that is malachite, caprite, and azurite, whose formula are indicated there. And then finally for lead, the chief ore for lead is galena, whose formula is that, lead sulfide. Then we also have the other ores for lead, that is cerussite and anglesite, whose formulas are indicated there, as I said. So you can see, like now for aluminium, we have the oxide, which we said some ores are oxides, sulfides, carbonates, zinc. You can see the oxide, iron oxide, sulfide. Then copper, we have the sulfide, the carbonate, the oxide. And then for lead, we have the sulfide, the carbonate, and even the sulfate, which is the anglesite. So you can see most of these ores are either oxides, sulfides, carbonates, sulfates, or even chlorides. Now, we have some general methods of extracting these metals. So let's discuss the general method of extraction of the metals. So, general methods of extracting the metals. The first step is mining. So, after research has been done, then a particular area has been identified to be containing a particular ore of a metal. So, the first process will be mining, extraction of that metal from the ground. Now, there are two ways of mining. We have what we call open cast mining, which ordinarily we call it quarrying. Now, this is done for metals that are near the surface of the earth. Now, like for example, aluminium. It is said that 75% of Earth's crust is made of aluminium, meaning aluminium is not found too deep under the ground, but it is found on the surface. So that would be step one, to obtain that ore. The other one, there are some other metals that are found very deep under the ground. For example, gold is usually found deep in the ground. Now, those ones, the method used is called deep mining, and deep mining might involve digging of tunnels. This will mostly involve digging of tunnels, dug until you reach where the mineral deposit of that particular metal is. So once you have mined, the second step after obtaining the metal ore, step 2 is what we call concentration of the ore. Concentration of the ore. So this, there are a number of steps that are involved in the process of concentrating the ore. Now, the main reason, the main aim for concentrating the ore is usually to increase the percentage of the mineral or the metal of interest by removing some of the unwanted materials. So there are steps that will be involved. So for example, step 1, you can remove, using a magnet, remove magnetic materials. You can remove the magnetic materials, so that's thereby increasing the percentage. Then after that, you can wash, because you are digging it from the ground. Definitely there will be sand, soil, the earthy materials that are not required. So second step will be washing with water to remove the earthy materials. So washing with water to remove the earthy materials. So, and the earthy materials I've said, for example, clay, sand, such, etc. So those materials mostly are you will find in some text, it is called gangue. So those unwanted earthy materials, generally we call them gangue. So you remove the gangue, which is those unwanted materials which I've given there the example. And then step 3, we have what we call further concentration. Now, this step 3, now there are metals that we concentrate. There are 2 ways of further concentration: froth flotation and the chemical leaching. So we have some metals will be concentrated by froth flotation. Froth flotation. Then others will be concentrated by what we call the chemical leaching. So first, what is froth flotation? So here, just use a very simple setup. So here you put so first you grind the ore to powder. So after it is ground to powder, and then it is, so mix it with water and oil. And then you agitate the mixture. Agitate the mixture connected by air at a high pressure. So let's say now here this is the mixture that you have. So this is, you have the powder form of the ore mixed with water and oil. Then now you blow in here air. So you agitate this mixture with air. So when you do that, when you agitate the mixture with air, then it is going to form a froth. Froth will be formed. Just say, like, now let me give you a simple example. Like, for example, when you take powder detergent, you put it in water, then when you want to wash your clothes, when you agitate the soap mixture with water, you see it produces what we call foam. So this is, in this case, the equivalent of the froth. So here don't call it the foam, but the froth. So it will produce that light substance, so it will swell above here. So you can use technically here a Eureka can do that. Then you will have here another container here. So the froth, as it swells up, it starts getting out there, and then you can collect it in another container there. So this froth, it is rich in the mineral ore. So usually what happens as you agitate, the oil particles surround the mineral ores. And then as it swells up, it moves up with those mineral ores there and cross in the froth. The other materials, the heavy materials, will settle at the bottom. So these are what we call the sediments. So you can call it sedimentation process. So the heavy materials will collect at the bottom, or in other words, it will be equivalent to that. Again, the other materials that were not removed by washing, they'll be removed here. So what is collected here, the froth that is collected or settling here, it is rich. It has higher percentage of the mineral compared to what was initially put here. So this is how we do the froth flotation. That will be the froth flotation process. The other method, there are other metals. Now, in fact, before we go to the other method, the metals that are concentrated by this method, example of metals that are concentrated by this, as we are going to see, will be zinc, lead, and copper. So these three, as we are going to look at the methods of extraction, we will just mention. So that particular point will not have to go through this entire process. But generally, then this will be the when we talk about froth flotation, we say that they are concentrated by froth flotation. Then this is the process that we mean by froth flotation. And then the other method of concentrating, if you don't use the froth flotation, where concentration has to be done, then there is what we call the chemical leaching. Chemical leaching. Now, in this process, a suitable solvent is used, and then the ore, after being ground into powder, it is dissolved into the ore. So here again you will have, you grind the ore to powder. The reason for grinding is to increase the surface area. To increase the surface area. So you grind the ore to powder to increase the surface area. After that, then you can dissolve in a suitable solvent, in which the material of interest, the metal of interest, will dissolve in the solvent, while the other materials will not dissolve. So then you can now filter. Then from the filtrate, now you can obtain your metal of interest. So then from there, filter to obtain concentrated ore as a filtrate. So the ore that you want mostly, then it will be in the filtrate. And the best example that we are going to use, a good example here will be aluminium. Extraction of aluminium. Aluminium is concentrated by this method, chemical leaching. So we will see that when we'll be looking at extraction of aluminium, we will discuss all those steps in detail. So the chemical leaching process might differ from one metal to another, also depending on the type of impurities that are contained in that metal. So we will elaborate on the chemical leaching process when we will be discussing the extraction of aluminium. And then lastly, the very last step that we are going to consider is going to be the not very last. We have, after that, we have the reduction process. So we have 4 steps. So this step 2 was concentration. So then step 4 is a reduction process. So after the ore has been concentrated, then step 3 is a reduction process. Now, under reduction process, we have two ways in which reduction is done. So we can have a reduction by electrolysis process. Reduction by electrolysis process, and the other method is reduction using coke, or if you like carbon reduction by using coke or what you call carbon. Now, for you to use this method, there are factors that you consider. So, it will depend on the position of the metal in the reactivity series. So, in fact, reduction using carbon, if I forget, this is in other terms what we call the smelting process. When the metal ore is reduced by this method, we call it smelting. So as I was saying, which method to use? Whether to reduce the metal by electrolysis or by carbon, it will depend on the position of the metal in the reactivity series. Though electrolysis can be used to extract, to reduce any metal, sometimes it is very expensive because of the cost of electricity. So you might resort to have to use carbon, because this one is usually relatively cheaper compared to electrolysis. But there are some, even if you want to use coke, it will not be possible, because for metals that are more reactive, that are above carbon in the reactivity series, you cannot use this method for their reduction. So let me just write for you the reactivity series. We have the metals very fast, and then we go through it. So here we have the reactivity series of the metals as we commonly know it. Now, I have placed carbon. Carbon, it is not a metal, but I've placed it in the reactivity series to show you the position of carbon in the reactivity series. So this is the position of carbon in the reactivity series. Can be placed between aluminium and zinc, or that is aluminium and manganese. We rarely discuss this, but I'll just also point it out because that is the position of manganese in the reactivity series. So these ones, all these ones that are above carbon, all these metals, so these ones are extracted or reduced by electrolysis. So these metals usually are very reactive. You cannot find them free. They are usually found combined with other elements. And then we have here this group of metals. These ones are more moderately reactive. They are found usually combined with other elements, mostly as oxides, carbonates, or sulfides. So these ones are reduced by coke, or if you like, by carbon, and also carbon 2 oxide, because when carbon burns in a limited supply of oxygen, it produces carbon 2 oxide, as you are going to see the main reducing agent, carbon and carbon 2 oxide. Then, so these ones are moderately reactive. So these ones are very reactive elements. These ones are moderately reactive. And then these are least reactive. So some of these are usually found just as free elements, just like that. For example, gold, just found as just gold, platinum also. So some of these are just found, but they can also found combined as particularly the oxides. So these ones can also be, so these are usually reduced by roasting, so you can just roast them with a more reactive element and or carbon. So reduced by roasting. So if you roast them, particularly with carbon, you can see carbon is much above them. So carbon will take away the oxygen. So they are mostly found as the oxides, mostly. So that is how they will be reduced. Then finally, the fourth and the last step is purification. Under purification, there are three ways of purification. The first method of purification is by electrolysis. The other method and here, we'll give an example. For example, you can have copper. As you will see, copper is purified by electrolysis. For the metals that we are going to discuss, we can have purification by distillation. So this one we are going to see or to discuss it when we'll be looking at extraction of zinc. And then you can also have purification by oxidation, and this I'll discuss the oxidation process in detail when we'll be looking at extraction of iron. So the electrolysis, this I have explained this one much in detail or briefly under application of electrolysis in lesson number 12 for those who are following the topics that I was doing in the last the topic that I did on electrochemistry, lesson number 12. I have elaborated practically showing how that is done, electrolysis. So purification I've mentioned there, but also I will revisit that point again, that area, when we'll be looking at extraction of copper and its purification. So these are the general steps. So step 1, mining; step 2, concentration; 3, reduction; and 4, purification. Those are the main steps that are followed, but not all metals will follow this process up to here. Some just end much earlier, particularly here, reduction by electrolysis. Most of those that are reduced by